Hello and welcome. In lesson 1.9, transformations, titled Transformations, Translations, you will compare and contrast a rigid transformation from a non-rigid transformation and identify translations on functions. Now, a transformation is any change in position, size, or shape of a parent function. And a rigid transformation is a transformation that doesn't change the shape of doesn't change the size or the shape of our pre-image. Like, for example, reflecting it, rotating it, and what we're going to discuss in today, translating it, translations. So a translation is an example of a rigid transformation where all we're doing is simply sliding this object up, down, left, or right. So let's go into the notation of sliding a function vertically. To slide a function vertically, what we're doing again, if we label this function here, this one right here, the complete one, f of x, we're sliding this function vertically to this new position here that I'll highlight in red, and we'll call this g of x, by adding some constant to that value of f. So to the entire parent function, we can shift it upwards by adding this quantity of c to, again, the entire function itself. And what's resulting is that we are getting the x and y coordinates of our function and changing it by adding simply this value of c to all of the y values. So that's what, again, this notation stands for. Remember, f of x is the exact same thing as y. So we're changing, again, all of our y values by sliding them up, keeping the same x values, but sliding up the y values to the new location, which is going to be c units higher. Now, to slide the function downwards to this notation right here, to this graph, which we'll call h of x. H of x is the result of subtracting a constant from the function itself. So we slide it downwards and not just all of these points get slided downwards by c units, and that's expressed mathematically by subtracting a constant from that function. And what's happening here in terms of coordinates of x and y coordinates is that the x and y coordinates are changing by keeping the same x value, but subtracting, again, a constant, this value that we're sliding downwards, to all of the y values. So for example, this function here is going to slide this graph 4 units down. Because we're subtracting 4, this is going to shift our parent function, which is x to the third power, 4 units down. Now going back now to the other direction for a horizontal translation. In order to translate this horizontally to the left or to the right, again along the x-axis, that's going to add or subtract the value to the x coordinates. So if we call again the original function, this function right here, f of x, and we'll call this function here, shift it to the left, g of x, we get g of x by adding a horizontal shift or a horizontal value to that quantity of x. So by shifting it to the negative side of the origin of 0, 0 and shifting it to the left, we don't actually subtract this value, we actually add that value. Of course, this is what it looks like again algebraically. What's happening again in terms of x and y values is that in terms of x and y values, adding again this value of h, since we're shifting it h units to the left, it's decreasing. It's going to decrease all of the x coordinates by that h, by that shift on the other side. And I know it looks confusing because over here we're saying that we're adding that quantity, but in fact, by adding this, what's really happening is that we're shifting again our x coordinates by decreasing it to the left. We're subtracting that quantity h units again to the left, which again mathematically means that we're subtracting that value to our x coordinates. And because this happens again moving to the left, then moving to the right, the opposite is going to occur. So if I was going to shift it as again h units to the left, we'll call this h of x. Is that our function is going to subtract that quantity to the x. So again, in terms of x and y values, again, shifting it to the right again is going to add a quantity to the h. It's going to add the quantity h to the x coordinates, but in terms of how that is expressed as an equation, and algebraically again in form of equation, we say that that number is being subtracted from our x coordinates. Our input value again does this. So subtracting again h from our x coordinate is going to shift it to the left, to the right, to the right, and adding again is going to shift it to the left. So you end up again moving in those directions there. So like in this example right here, like we said, this right here, because it's on the outside and we're shifting again and subtracting 4, this is going to be a shift, a vertical shift, and the -4 is going to be down. Now in this example, because it's grouping again the x with the +7 together, this is going to be a horizontal shift. So this is going to shift left or right. Specifically, because we're adding 7, it shifts it to the left. So in order to indicate when we're moving vertically and horizontally, it depends on whether we're adding again to the function, to the, in this case, the reciprocal function, or to the input value. So right here, since the adding 7 is grouped with the x, this is going to be horizontal. And specifically, this is going to shift it's going to shift 7 units again to the left. And the parent function to this is 1 over x. So we're going to shift the 1 over x function 7 units to the left. This equation right here, again, because we're grouping the x minus 6 together, that's going to be a horizontal shift. So this is a horizontal translation. And since we're subtracting 6 with horizontal, it's the opposite. It moves in the opposite direction. So the notation of -6 doesn't shift it to the left, but shifts it to the right. So this is going to shift our cubic function, our square function, our quadratic function, square function, 6 units left. Right. I drew the arrow to the right, and for some stupid reason, I wrote left, but right. There we go. On this example, same thing. Again, the absolute value works as a grouping symbol. So here we're adding x, we're inputting x plus 5. So that's again our input value. So we're doing a horizontal shift. Or horizontal slide, so horizontal translation. And the 5 is going to shift again our absolute value function 5 units again positive, shifts it to the left. Now in this next one, it does both translations. The x minus 4, that is going to be a horizontal translation. And the plus 6, which is on the outside, that is a vertical translation. So starting off with the with the horizontal one, well, the minus 4, that shifts things again to the right. So we are going to translate this and slide this square root function 4 units to the right. And the plus 6 is going to slide again the square root function 6 units up. And this one, again, we have two translations. We have a horizontal one and a vertical one. So our horizontal translation is going to shift again the cubic function, that's the parent function, the cube root function, not cubic, but the cube root function 2 units to the left. Remember, with horizontal is the opposite. Adding actually moves it to the left. And the red one, that is going to be a vertical translation, and that's going to slide again our cubic function 9 units down. And that one again is just straightforward. Subtracting means down, positive means up. But with the horizontal one, it's the opposite. Now, using again that idea, we're going to identify what the parent function is and then write the equation to this function. So right here, we're using the fact that this equation again is x to the second power. And because x to the second power, again, normally is a parent function that goes through the origin, again, that looks like this, through the origin normally, we're going to see where the new location is of that point that was originally at the origin, because that's easy to identify, which is that point right there. So from the origin, again, that turning point, that vertex, has been shifted 2 units to the right. So as a result, the function for this should be, let's call this h of x. H of x is going to equal to this parent function of x squared shifted to the right. Well, to shift it to the right, we are again affecting the x coordinates, and moving it to the right is going to subtract that 2 and not add that 2. So the equation to get this graph, this x squared graph shifted 2 units to the right, would be x minus 2 to the second power. Now, to shift it to the right, again, this point, again, was originally again at the origin, is now down here. To shift it to the right 2 units and also down 5 units is going to result in, again, like before, subtracting 2 to the x and subtracting 5 to, again, the parent function. So if I slide it down, that will be x squared minus 5. And to slide it to the right would be x minus 2 to the second power. And putting those together, those two translations, those two slides together, is going to create this. Now let's look at another function. Let's see how this works with another function. You'll see again it works the exact same way. So here again is a translation of this parent function, the cube root function. And normally again the cube root function again looks the same way, but this point here is normally here at the origin. So comparing again this point here from the origin, we can clearly see that this graph along with that point, along with the rest of the graph, has been slided up 4 units. So we slid up 4 units. So it's been shifted 4 units up. Sorry, it's kind of weird saying either of those words. So what does that mean? Well, in order to slide it up, that's going to add again 4 units to all the y coordinates to the graph. And we denote that by adding 4 again to the parent function like this. So we don't put it inside the cube roots because that would result in a horizontal shift when we put it on the outside essentially. So we put it on the outside and that's going to slide it up. Now if I want to slide it up and to the side, as you see right here, which is a slide of 5 units to the left and 4 units up, well, this sliding of 5 to the left is going to again affect the x coordinates. So we're going to put that translation inside the cube root. So our function of h of x for this translation here would be the cube root of x plus 5, since we want to slide it to the left, and then the plus 4 again goes on the outside. So any operation on the inside is going to affect it horizontally, and any operation on the outside is going to affect it vertically. So like this one right here. Now for this one right here, the focal point on this one, from the origin, is this point right there. Normally, again, we see that this graph again is disconnected at the origin, which is now at this location there. So for this one, this thing has originally been slided or has been shifted 5 units to the left. And because again it's a horizontal shift, that's going to affect again the x coordinate and not the entire function itself, not the output values, but only the input values. So we're going to write that h of x, the transformation of this function, is equal to 1 over x plus 5, since we're sliding it to the left. Now if I slide it to the left and also down, so you see where this point is right there, that's the focal point that was originally at the origin. If I slide this point 5 units to the left and 6 units down, then the function h of x now is going to look like this. We're still going to have the x plus 5 in the denominator to shift it again horizontally 5 units to the left, and to move it down 6, we're going to subtract 6 to that function. And this is what the equation will look like to this graph. Well, that concludes again our lesson on translations. If you do have any questions, again, please send me a message or remind or email. Again, thank you for watching, and I hope you have a great day.